Bismillahirrahmanirrahim. Dear students, today we will do the new topic for grade 11, and this is the lecture number 68 for the grade 11 and chapter number 12, last chapter. And the last topic of this chapter is electron potential according to your revised, reduced syllabus. Electron potential after balancing chemical equation. Here the electron potential. Electron potential and electrochemical series. This is the topic number 12.2, electron potential and electrochemical series. Dear student, in grade 9, you done the two types of cells. There are two types of cells. Number one cell is called galvanic cell. When chemical energy changes into electrical energy, and the reactions are spontaneous, redox reactions. And second cell is done. Galvanic cell is also called voltaic cell. Another is a electrolytic cell. Opposing here electrical energy changes into chemical energy, and these redox reactions are non spontaneous. These are the two cells we use. Then the case 1, there is a chemical and they react and generate electricity, just like we use battery cells. Small batteries we use in the calculators, we use in the cell phone, we use in the toys, we use in the wall clock. There are many others also, time for this wristwatches also. So these are the galvanic cells, car battery. These are called galvanic cells. And there are two galvanic cells, rechargeable and non-rechargeable. Cell phone battery is a rechargeable battery, and we buy small batteries from the market and put in the calculator and put in the wristwatches and toys. These are the non-rechargeable, but there are also rechargeable. So there are two types of the galvanic cells, rechargeable and non-rechargeable. So here we will see the redox reaction according to your topic, and you done also in grade 9. In grade 9 you done. So students, we are going to construct a cell. This is the type of galvanic cell. This is a type of galvanic cell, but it was used Daniel. That's why this cell is also called Daniel cell. So there are two containers. These two containers contain 1 molar solution of zinc sulfate, 1 molar solution of copper sulfate, and here you have to dip in a solution zinc anode, and here you have to dip copper, zinc acts as a anode and copper acts as a cathode. So when you are going to dipping the electrodes according to diagram you can see in your book. So this is the zinc. This is zinc. So zinc, these zinc metal changes into zinc ions. There will be oxidation on the zinc. Zinc is going to be oxidized and there is a sulfate there. So zinc metal changes into zinc ions by the removing of electrons. By the removing of electrons. So there is a oxidation here. And 1 molar solution of zinc sulfate is going to be added. And here copper inverse. These copper ions from the solution to form a copper metal here. Inverse of this one. Copper ions change into copper metal and here zinc metal change into zinc ion, and there is oxidation at anode and reduction at cathode. Dear students, let us know Daniel cell, which is a galvanic cell or voltaic cell. Spontaneous redox reaction taking place. So we have to connect these two solutions together. We use a salt bridge. Salt bridge is going to be used. Here we put the cotton. Just must be flowing of only ions, no solution. Solution is not going to be flow. And there is a salt bridge. It contains salt, and there are many kinds of the iron salts are going to be put in the added in the salt bridge. You can put the sodium sulfate, potassium chloride, potassium iodide like this one. So salt bridge, sodium ions are going to be towards copper. And sulfate ions are going to be zinc. There the flow of ions So zinc oxidized by the loss of electrons and copper reduced by the gaining of electrons. So here electrons are leaving, that's why negative. Here electrons are entering, that's why positive. Electrons are entering, that's why positive. And we connect here by bulb. The bulb will be glow because we are going to measure electrode potential. So that's why you have to connect with the volt meter. We connect this by voltmeter here. So there's a detail of voltmeter here. So what happens when you are going to connect these electrodes? Connection of electrodes, and there is a written here. Solution is there. Now oxidation reduction taking place here, and the voltmeter will show the voltage. So this voltmeter needle is going to be moved and it will show 1.10 volt, which is called the electrode potential, and the force which is required to move the electrons from anode to cathode, electromotive force. Movement of electrons always from anode to cathode. This is the moving of electrons, where from the anode to cathode the force is required from the electrodes to flow the electron from anode to a cathode is called electromotive force, we call EMF. So the voltage of the electrode potential is EMF is 1.10 volt. So zinc is going to be oxidized and copper is going to be reduced, and the total current is going to be generated by using this cell is a 1.10 volts. Now I am going to write the reactions here. At anode. At anode always oxidation, zinc changes into zinc positive 2 solid by the loss of 2 electrons, and there is oxidation, real oxidation taking place, and at cathode reduction takes place, and copper ions, 2 electrons gained to form copper metal. So zinc is going to be oxidized and copper is going to be reduced in this cell. But this typical cell is called a Daniell cell, because the Daniell he first used this zinc and copper coupled cell first time. That is why this galvanic cell he named, or voltaic cell he named as a Daniell cell. So spontaneous redox reaction taking place. No electric current is used here. solutions when they are going to interconnect with each other by using a salt bridge, which is going to be made inside ions with a gelatin. So this is a salt bridge, and which connects these two solutions together. These electrodes, this is a cathode and this is the anode, are connected with the voltmeter or bulb. So when it is bulb connected, bulb will be closed. Or you put the voltmeter, the voltage will come 1.10 volts is going to be generated in this cell. No electricity is going to be passed, but electricity is generated here by the chemical reactions. These redox reactions are going to be spontaneous. Now there is one question here. The question is that when you are going to construct this cell, and when the cell is going to be works, zinc is oxidized and copper is reduced. Zinc acts as an anode and copper acts as a cathode. But why not copper acts as an anode? Why the zinc anode? Why not copper? Same, you are putting the copper metal with its own ions, copper ion with sulfate, 1 molar solution, and you are also dipping zinc metal with its own zinc ions, connection salt bridge, attaching with the voltmeter. Why the electrons flow from the zinc to copper? Why not from copper to zinc? Dear students, there the topic you will do electrochemical series. According to electrochemical series, if you look in there is a table 12.1. These are all reduction potentials, standard reduction potentials. According to the agreement, IUPAC system, these are all published reduction potentials. They are all, if you see the table, all the electrons are on the right side, all. So they are the very important thing. The half cell in all reduction potential, I say, in all reduction potential at top you find the maximum negative value. So the reduction half cell which has more large negative value is going to be oxidized. And the reduction half cell which is going to be more positive value is going to be reduced. So dear student, if you look at this table, you will find that the reduction potential of zinc and reduction potential of copper, E naught cell reduction potential. So you will find this up top, and the value is a minus 0.76 volts, and copper plus 0.34 volts. Both reduction potential. So students, I told you according to the agreement IUPAC, this is published as a reduction potential. These values are calculated. Zinc is on the top, which has a minus 0.76 volts, and copper is down, then hydrogen is standard, which has a plus 0.34 volts. So the reduction half cell which has more negative value, large negative value, acts as an anode. zinc is going to be oxidized. Zinc is going to be oxidized, so that is why its E naught cell value will be plus 0.76 volts. This is the reduction. Positive 2 changes into 0. Reduction minus. When oxidizes, the value will be same, but the charge is going to be changed. And this copper E naught standard cell is equal to plus 0.34 volts. This is the reduction potential. Already it has a plus 0.34 volts. This reduction potential has a more large negative value. That is why zinc is oxidized, and copper has a more positive value. That's why it is going to be reduction, cathode. And there the one also page you can see active metals. There the one series you can see. So zinc is more active than the copper. Zinc is more reactive than copper. So dear students, more active metal can displace less active metals. More reactive metals can displace less reactive metals. So zinc is more reactive, so it can displace copper from the solution. So that's why zinc is going to be oxidized and copper is going to be reduced. So according to the electrochemical series, we have a formula. I will do this how we calculate. When you add both, so you will get 1.10 volt. Total voltage of this cell is a 1.10 volt. This is the galvanic cell, or we called it Daniel cell, or we called Voltaic cell here. Dear students, this whole voltage electrode potential for the both oxidation half cell and reduction half cell. This is oxidation half cell and reduction half cell. So if we don't see the electrochemical series, if we don't know these two values, I don't know. Suppose I am doing another one, I don't know about this, and you know only this because this voltmeter shows sum of these both. So by using this Daniel cell, we will be unable to calculate the electrode potential for the half zinc cell or half copper cell. This is the only total. This is a total. So if I don't know about both or one of them, so I am unable to calculate the half cell for like this for plus 0.76 and plus 0.34. I don't know about this. So by using this cell, I am unable to calculate the electrode potential of one half cell. This will give you only total, which is measured by the voltmeter, or you can put the bulb, it will glow. This is the disadvantage of this cell. Dear students, potassium chloride, potassium nitrate, sodium sulfate can be used as a salt bridge. Salt bridge is only allowed the movement of ions from one solution to other solution without mixing two solutions together, and also it maintains the electrical neutrality of each half cell. These are the uses of the salt bridge. In one half cell, oxidation takes place is called oxidation half cell reaction at anode. When other half cell, the reduction taking place is called reduction half cell reaction. So these half cell reaction complete to give a complete redox reaction. Zinc is going to be oxidized and copper is going to be reduced. Already I told you. Oxidation occurs at anode and reduction occurs at always cathode. So this is the Daniel cell. Now electrode potential. Dear students, cell potential 12.22. The cell potential for the galvanic cell already I mentioned is literally potential of the cell to do work on its surrounding by derive an electric current through a wire. The work that can be accomplished when the electrons are transferred through a wire depending upon the push of force behind the electron I told you, which is called electromotive force. The force with which electrons are pushed to flow through the wire from anode to cathode is called EMF or electromotive force. Already I told you it is measured in volts, so total electrode potential was 1.1 volt for the whole cell. So the volt is a measure of energy that is capable of being extracted from the flowing electric charge, volt. When the passage of 1 coulomb is able to accomplish 1 joule of work, then the EMF is called 1 volt. When the passage of 1 coulomb is able to accomplish 1 joule work, then EM is called 1 volt. So EMF is produced when a galvanic cell is E potential, electrode potential we call this one. So EM produced by galvanic cell is called electrode potential. Again I am telling you, the EMF electromotive force produced by a galvanic cell is called cell potential. It depends upon difference in electrode potential of the two half cell I told you joined together. Cell potential for the zinc copper couple is 1.1 volt. Thus, I told you this again. If you see the electrochemical series table, thus the electrode potential, the more negative reduction potential. More negative reduction potential acts as an anode, and more positive electrode potential shows cathode. The net reaction that occurs in the galvanic cell under the standard conditions. Standard conditions means 1 molar solution you have to use, 1 atmospheric pressure, 298 Kelvin means 25 degrees Celsius, not 0 लगाते हैं ऊपर हम. It's called standard. The constructed from the standard reduction Hausser reactions, since redox reaction must include both oxidation and reduction, so that is why spontaneously they are going to be flow. So more negative potential, more positive electrical potential. This means that under standard conditions electrons are produced by the reaction with a more negative standard potential and consumed by the reaction with a more positive standard potential. So E naught cell, I told you, which is going to be measured at standard condition, already I told you. So we have here formula and you have to remember it this. Total cell potential at standard states can be calculated by E naught cell cathode minus E naught naught cell anode. So we will use this formula. E naught cell cathode minus E naught cell anode. So dear students, the cell potential has a positive value. After the calculation, if you have this cell potential positive, it means that the reaction is a feasible and spontaneous. The redox reaction is feasible and spontaneous. If it comes negative, then the reaction is non-spontaneous or not feasible. The reaction half cell, however, relative half cell potential, electrode potential can be determined. This is very important. Dear students, in grade 9 there was one box I told you in the chapter number 7. If you see the electrochemical cells in the chapter number 7, grade 9, there was one box, but they were not explained by the author what kind of this cell is, but I explained in the class, all of you, grade 9. I told you galvanic cell is not helpful to calculate the electrode potential for the each half cell, oxidation half cell or reduction half cell. We calculate total cell potential by using this one. So that is why we use one cell. We use one cell which is called standard hydrogen electrode. We use standard hydrogen electrode. Standard hydrogen electrode, either it is going to be oxidized or reduced. Its cell potential is always 0. That is why it is standard, and you can see in middle of the electrochemical series table. If you see the series up, you can see all negative values. It means that all these are going to be oxidized and standard hydrogen electrode will be reduced. But below the hydrogen, they will all reduce and standard hydrogen electrode will be oxidized. So standard hydrogen electrode oxidizes or reduced, its E naught cell will be always 0. So dear students, if I connect this standard hydrogen electrode with another unknown half cell, zinc, copper, iron, cadmium, any, chlorine, iodine, with any you have to add, dear students, you will get only the E naught cell for that half cell. And the borderline I told you, if you see the electrochemical series table, up above the hydrogen, all they have negative values. They will be oxidized and the hydrogen standard will be reduced. Below the hydrogen, all they have a positive values. So hydrogen will be act as anode, oxidizes, and all other will be act as cathode. So now this is the function of the standard hydrogen electrode. Now I am going to construct this cell. This is the container. This container contains 1 molar solution of HCl, bubbles, 1 molar solution of HCl there, and there is a platinum wire coated with the platinum foil. This is the platinum wire, and this is the platinum foil. Here hydrogen pass at 1 atmosphere, work as 298 Kelvin, 1 molar solution at their standard states. So this is a glass sleeve. This is a glass sleeve. All this is made of glass. Hydrogen is passed through 1 atmosphere pressure. 1 molar solution is here for the hydrogen chloride, and there are the hydrogen ions inside. And this is going to be electrode is going to be connected with the copper, with the zinc, with the chlorine, with the bromine, with the iron, with the cobalt, with the lead, with the tin, magnesium, calcium, water vapor. And I told you that this is the middle up. These are negative. So this will be act as a cathode, and reduction 0, and you will get the result of the that unknown electrode or half cell. This is the standard hydrogen electrode. Standard hydrogen electrode consists of platinum foil coated with the finely divided platinum metal surrounded by the hydrogen gas at 1 atmosphere pressure. 1 molar solution of the hydrochloric acid is added at 1 atmosphere pressure at 298 Kelvin. So dear students, if the standard hydrogen electrode is oxidized, it gives 0, and it is going to be reduced, it also gives the 0. So you can see the electrochemical series. Here the hydrogen shows 0. So this will be a reference cell because it will give the 0 voltage, and you can put here another cell to calculate the standard hydrogen electrode for the other. Just like suppose here I put copper. I want to calculate copper. There is 1 molar solution of copper sulfate, and here must be a salt bridge to connect these two solutions together. You done before, and there is a voltmeter to connect these two cells together. This is a voltmeter, and I told you copper is below the hydrogen. Copper is below the hydrogen, so that's why this standard hydrogen electrode will be oxidized, but its value is 0, and this copper is going to be reduced. Copper is going to be reduced to give copper metal, and E naught cell will be plus 0.34 volts. So here plus 0.34 volts will this will show by the needle of the voltmeter. So this will be given by this. You done this now. Electron will flow from the anode to cathode like this. Electron always flow from anode to cathode, so you will be able to calculate it even for the this galvanic cell. So thank you very much. Here we stop. In next lecture, I will going to be solve a very simple numerical by using this formula. The reaction will be spontaneous or not. Thank you very much.